For decades, the dream of reaching space has been synonymous with fire and fury. Each rocket launch, a violent spectacle, consumes $5 million in fuel simply to escape Earth's gravity. Most of the colossal structure is then discarded, burned to ash, or plunged into the ocean, a testament to the brutal inefficiency of our current methods. This is the reality of space travel today. But what if the journey upwards required no explosive force, no massive fuel consumption, no single-use hardware? What if, instead, humanity could simply ride a silent electric elevator, ascending along an impossibly long cable stretching directly into the cosmos? This is no longer the realm of pure science fiction. The Obayashi Corporation, architects of Tokyo's towering skyline, now sets its sights far beyond the clouds. Their audacious proposal, a 96,000-kilometer cable anchored to a massive floating port, with a target completion date of 2050. This space elevator would operate on electricity, eliminating the need for volatile fuels, explosions, and the endless cycle of discarded rockets. Yet the entire colossal endeavor hinges on a single, revolutionary material, one not yet mass-produced. Carbon nanotubes, with their unparalleled strength, are the theoretical backbone of this vision. Without them, the cable cannot be built. The stakes are immense, and the future hangs in the balance. Right now, at this very moment, a critical test is underway. Scientists from Shizuoka University are evaluating a sample of this material aboard the International Space Station, exposing it to the harsh vacuum and radiation of orbit. That tiny test sample, no larger than a human thumb, represents the fragile bridge between a daring concept and a concrete construction site. The sheer scale of the project demands engineering on an unprecedented level. It begins not in a clean room, but in the gritty reality of a shipyard. Here, skilled workers use plasma torches to carve 40mm steel plates, precisely curving each massive section. These are then meticulously welded to form a 400-meter floating ring, the very foundation of the spaceport. Each of its 24 watertight compartments is sealed, then rigorously flood-tested. A single microscopic leak could condemn the entire port to the ocean floor. Section by section, the colossal ring takes shape, every join aligned with an almost impossible precision, to within 2 millimeters. Underwater welders descend into the depths, their arcs blazing as they seal the base joints, creating bonds designed to withstand the relentless equatorial ocean for 100 years. Inside each compartment, ring frames are fitted every 2 meters, a skeletal structure ensuring the hull's absolute rigidity. Even the slightest flex could compromise the cable mount, the critical connection point to Earth. 48,000 tons of ballast concrete are poured into the base cells, an immense weight designed to prevent any tipping or instability as the port navigates the open sea. From within its cavernous hull, the second century in the most unforgiving marine environment. 12 powerful thruster pods are then meticulously fitted to the hull, providing the precise maneuverability needed to steer the 400-meter ring across vast stretches of open ocean. Finally, the deck is laid, prefabricated sections lowered into place, aligned with painstaking accuracy, bolted and welded flush. Ballast lines, a complex network of pipes and conduits, snake from the hull to the control room, each valve and flange painstakingly fitted by hand. The space elevator's cable will be the tallest object ever conceived on Earth, an irresistible magnet for the planet's most potent electrical discharges. Massive lightning conductors will ring the entire deck, designed to channel and dissipate the raw power of nature's fury. Even the mooring chains, anchoring this leviathan to the seabed, are a feat of engineering, weighing 6,000 tons, each link forged from high-strength alloy steel. As the completed hull finally departs the shipyard, workers line the deck, witnessing its inaugural journey into open water. From the center of the ring, the terminal tower begins its ascent, 3 meters of intricate steel lattice rising straight upwards. Power cables are carefully pulled through the tower legs, every circuit meticulously routed before the next complex system can be integrated. Sensors are embedded into every tower leg, constantly monitoring the immense stresses and strains. This is more than just a structure. It is a gateway. A 96,000-kilometer thread weaving humanity's future into the very fabric of the cosmos, transforming the violent journey to space into a serene, electric ascent. From the very first second, every tremor, every minute deviation in the cable's taut line is measured. A constant, unblinking vigilance, for its vibration is the heartbeat of a colossal machine, a living artery extending into the void. On the churning surface of the equatorial ocean, the climber loading dock begins to manifest. Guide rails, massive locking arms, and the intricate mechanisms of a maritime marvel take shape. This Leviathan structure is engineered for a singular, monumental purpose: to receive and secure a vehicle weighing a full 100 tons, docking not in a calm harbor, but amidst the relentless fury of the open sea. Every bolt, every beam, every welded joint across this vast platform is dedicated to one ultimate objective: to grip that descending cable, the umbilical cord from orbit, and never, under any circumstance, relinquish its hold. A self-sustaining city blossoms upon this artificial island. Desalination plants, power generation facilities, and comprehensive sewage treatment systems are installed simultaneously. A ballet of complex engineering and logistical coordination. Below deck, 6 generator sets are meticulously integrated, forming the beating heart of the port's energy supply. This port, a critical nexus between worlds, cannot afford a single moment of power loss. Ever. Above, on the main deck, the laser transmitter dish is painstakingly assembled. This colossal array represents the conduit for energy itself. When the mighty climbers begin their ascent, the immense power required to propel them skyward will beam directly from this very point. Around the tower slot, where the cable will ultimately emerge from the depths of space, the crucial entry seal is fitted with absolute precision. This opening, a potential vulnerability, will face the full, unyielding assault of storm-driven seas, waves that seek to breach and flood. But it will not yield. The engineering ensures it. On the aft section, the helideck reaches completion. This vital area serves as the sole means of ingress and egress, a critical escape route in the event of an emergency, and the designated point for routine crew changes, a lifeline connecting this isolated outpost to the world below. Within the heart of the structure, the control room is meticulously fitted out. Every screen, every panel, every intricate control is fixed into place, creating the nerve center from which all port operations will be managed permanently. The vigilance here is absolute, the responsibility immense. Across every walkway, full arrest rails are installed, a testament to the unforgiving environment. The deck crew, navigating the vast expanse of the platform, must contend with the raw, untamed power of equatorial storms, which rage without pause, without mercy. Then, the moment arrives. The Earthport reaches its designated station. Thrust ignites, a controlled inferno propelling the colossal structure into its precise orbital alignment. Chains tension, groaning under the immense strain. Workers, their faces etched with a mixture of anticipation and apprehension, watch the gauges, holding their breath, holding steady, as the ultimate connection point is secured. The cable, the very backbone of this audacious dream, begins its existence not in space, but deep within the controlled environments of Earth. Here, within an array of chemical vapor deposition, or CVD reactors, carbon nanotube fiber is grown, atom by painstaking atom. Each thread is drawn off the reactor onto a collection drum, a continuous, uniform filament, utterly devoid of defects. The standard is absolute. Any imperfection, any deviation, and the process is immediately halted. It begins again, from zero. Hundreds of these pristine CNT fibers are then carefully combined, twisted into yarn. The twisting is not merely for bundling. It is a critical engineering choice, designed to ensure optimal load sharing across every individual strand, maximizing strength and resilience. These yarns are then meticulously bound into ribbons. Heated rollers press a specialized polymer matrix through the tightly woven fibers, embedding them, giving the ribbon its final, robust form. A protective coating is then deposited onto every single surface of this ribbon. Without this crucial shield, the relentless assault of cosmic radiation would strip the carbon bonds, unraveling the material's integrity in a mere matter of months. Each section, once coated, is then subjected to intense scrutiny, imaged under electron microscopes. A gap in the coating, however microscopic, is understood as a catastrophic gap in protection, an unacceptable vulnerability. 20 tons of this extraordinary material. That is the seed cable. It weighs less than a conventional terrestrial truck, yet it is engineered to bear a load equivalent to an entire skyscraper. The ribbon is carefully wound onto precision spools, each turn maintained under rigorously controlled tension. A single kink, a solitary imperfection in this winding process would guarantee the catastrophic failure of that entire section upon deployment. Once wound, each spool is sealed within inert gas transport canisters. Oxygen, even in trace amounts, would degrade the delicate ribbon, compromising its structural integrity. It travels, therefore, suspended in an atmosphere of pure nitrogen. At the launch facility, each canister undergoes a multi-layered inspection immediately upon arrival, a final verification before it proceeds into the pristine environment of the clean room. There, the canisters are carefully mounted within the spacecraft, their precious cargo prepared for its epic journey. The deployment mechanism, a marvel of precision engineering, is hand-cycled by dedicated workers, every release tested, every function verified, before the entire assembly is oriented vertically. The deployment spool, its motor and its brake are installed, forming the critical system that will precisely control the rate at which the ribbon unfurls and descends towards the waiting port below. Finally, the fairing closes over the cable payload, a protective shell encasing the 20 tons of CNT ribbon, now poised to ride a rocket, soaring towards orbit, towards the ultimate connection. The final deployment system check proceeds with a hushed, almost reverent intensity. Every sensor, every drive, scrutinized. Technicians, their faces etched with a profound sense of purpose, methodically run through an exhaustive list, line by agonizing line, before the ultimate handover. This is not merely a checklist, it is a sacred covenant with the laws of physics, a silent promise to an unforgiving void. Now, the rocket begins to drink. 300 tons of liquid oxygen, a cryogenic river, flows into its cavernous tanks. The air shimmers around the colossal structure, a phantom breath of impending power. Workers, their gazes fixed on the trembling needles of 100 gauges, stand witness to this delicate, dangerous fueling. Each increment a heartbeat closer to the precipice of launch. One by one, with a slow, deliberate grace, the massive service arms retract, peeling away from islands descends, broken only by the distant calls of gulls and the faint hum of machinery. The rocket stands alone, a solitary titan against the vast canvas of the sky. Ready. A tremor, a low growl that deepens into an earth-shattering roar. Ignition. A column of fire, blinding white and orange, erupts beneath the vehicle, consuming the launch pad in a furious embrace. Slowly, then with an accelerating fury, the Leviathan rises, defying gravity, tearing a luminous path through the atmosphere. Its first audacious destination, the precise, unwavering point of geostationary orbit, 35,786 kilometers above the equator. Miles above the churning blue, a new silence takes hold. The spacecraft, now liberated from its booster, separates with a barely perceptible nudge. Micro-thrusters fire, a ballet of controlled force, orienting the delicate craft with an astronomer's precision. Below, an abyss of 36,000 kilometers of absolute nothingness stretches, an empty canvas waiting for its first brushstroke. Then, the spool begins its slow, measured turn. A ribbon, impossibly thin, almost ethereal, feeds out into the vacuum. One end unfurls downwards, a gossamer thread seeking the distant Earth. The other extends upwards, towards the unseen counterweight, a massive, inert mass poised to balance the colossal structure. This is the genesis of an impossible bridge. On the planet below, ground crews, their eyes glued to radar screens, track the ribbon's agonizing descent. It is a thread finer than a human hair, yet destined to span 40,000 kilometers of raw space. An invisible tether, falling, a whisper of carbon nanotubes against the roar of the cosmos. At the designated port, a specialized capture crew stands at their stations, a vigil spanning days. Their wait is a testament to human patience, their focus unwavering. Finally, a faint blip registers on the radar, emerging from the turbulent embrace of the clouds. An aircraft, specially modified for this singular task, executes a breathtaking maneuver, snagging the ribbon high above the overcast skies. With meticulous care, the precious cargo is lowered, foot by foot, to the deck of the port vessel. The ribbon, this slender filament of humanity's ambition, touches the Earth port for the very first time. It is a moment of quiet triumph, a physical connection between two worlds. Workers, their movements a study in deliberate precision, begin the painstaking process of threading the ribbon into the massive tensioning drums. Manually, with the utmost care, one guide roller at a time, the fragile material is coaxed into place. Then, tension is applied. Slowly, inexorably, the ribbon tightens. From the vast expanse of the Pacific Ocean, it stretches upwards, disappearing into the azure, culminating in the silent vacuum of geostationary orbit. One continuous structure. That single thread, vanishing into the boundless sky, now stands as the longest artifact ever conceived and constructed by human hands. A singular, unprecedented achievement brought into being by the power of just one rocket. The ribbon, now a taut, vibrating string, is anchored securely to the drum clamps. Technicians, their tools precise and practiced, apply the exact torque to every single bolt, ensuring an unbreakable bond. Load cells, sensitive instruments measuring the immense forces at play, hold steady, their readings a silent affirmation. This monumental structure is not going anywhere. Around the ribbon's entry point, a specialized weather enclosure is sealed shut. The microscopic salt spray, an insidious enemy, would swiftly corrode and destroy the delicate carbon nanotube material. With the final click of the seals, the workers complete their task, leaving the anchorage protected. Monitoring instruments, a network of vigilant sensors, are fitted to the structure. Should the tension fluctuate by even 1%, the control room, miles away, will register the change immediately. The control room confirms. Ribbon stable. The port holds its station. The seed cable is now firmly in place. But this is merely the beginning. Now it must grow. The specialized climbing vehicles, the very arteries of this nascent infrastructure, are forged in the industrial heartlands of Japan. Their heavy steel chassis, robust and unyielding, are welded with absolute precision within assembly jigs on the factory floor. each joint a testament to engineering strength. Magnetic linear motor units, the powerful sinews of these machines, are meticulously bolted to the chassis arms. These units are designed to grip the ribbon with an unwavering magnetic force, propelling the climbers upwards, defying the pull of the planet. Gripper rollers, essential for smooth, friction-free movement, are fitted to the motor housings. Every single roller, on both sides, is checked by hand, its smooth running verified by the tactile expertise of skilled engineers. Laser receiver panels, the eyes and ears of the climbers, are mounted to their undersides. These panels are not merely for navigation, they are the conduits for power, receiving concentrated energy beams directly from the earth port. No fuel, no cumbersome batteries, just pure, directed energy, a constant flow to sustain their ascent. Every exposed surface of these marvels is meticulously covered with advanced thermal blankets. From the balmy sea level to the frigid vacuum of orbit, the temperature swings by an astonishing 400 degrees Celsius. These blankets are the climber's armor against the extreme, unforgiving environment of space. A repair dispenser, a vital piece of self-sufficiency, is integrated into each climber's sidearm. Every vehicle ascending the ribbon carries additional lengths of the precious material, bonding it seamlessly as it climbs, continuously reinforcing and extending the structure. Finally, the cargo lock jaws, immense and powerful, are fitted to the climber's deck. These formidable mechanisms are engineered to securely hold a 100-ton payload, maintaining its grip for a full 7 days, an eternity in the unforgiving vacuum. Workers meticulously cycle every single jaw, testing its strength, its integrity, ensuring that when the moment comes, humanity's next great leap into the stars will be held firm. Deep within the intricate machinery of every single gripper arm, an uncompromising failsafe stands sentinel, the emergency brake. Should the colossal power grid falter, should the lifeblood of the system cease its flow, there is no hesitation, no uncertainty. The brakes engage. Before a single climber ever approaches the towering ribbon, it undergoes an ordeal of absolute scrutiny. A full electrical bench test, a crucible of simulated stress. Every drive is energized, every sensor interrogated, every minute fault meticulously identified and purged. Only when perfection is confirmed, when every potential weakness has been eradicated, is it deemed ready. The first Titan, a marvel of engineering, is prepared for its journey. Secured with heavy chains across every lug, its bolts torqued to precise specifications, it embarks on a 3-week odyssey across vast oceans, bound for an equatorial port. Upon arrival, a colossal crane, a leviathan of the docks, gently swings the immense structure from its supply vessel. Guide rails, perfectly aligned, receive it, guiding it into its designated berth. Workers, moving with practiced precision, thread the delicate yet immensely strong ribbon through the climber's slot. The grippers close with a definitive, unyielding embrace. The climber is now one with its path, fully loaded, fully committed. Lasers lock onto their receiver panels, an invisible tether of precision. Motors hum, then spin up, their power building. With an unwavering grip, the climber begins its ascent. The first movement is imperceptible, a glacial creep. Then, a steady, inexorable rise. The ribbon, a testament to human ingenuity, holds firm against the immense forces. This is merely the beginning. Across continents, cable factories operate without pause, their rhythm relentless, their output staggering. 510 reinforcement climbers, each a critical component of this monumental endeavor, await their turn. Load it, close it, send it up. A mantra of progress. Within the belly of each ascending climber, a sophisticated bonding head performs its vital task. With immense pressure and heat, it fuses new layers of reinforcement ribbon onto the existing cable, building its strength, layer by painstaking layer. In the control room, a symphony of data streams in real time. Every climber's precise altitude, the integrity of every single bond. A weak bond is not a failure, it is a signal. The climber halts, retreating to redo the section, ensuring absolute structural integrity. Even the most robust machines demand vigilance. Returned climbers are meticulously serviced on the dock. Worn rollers are swiftly swapped. Inspection sensors calibrated with microscopic precision. Then, without delay, they are returned to the ribbon, ready for their next ascent. High above, a silent sentinel, a satellite, crosses the cable's projected path. A moment of potential peril. Port thrusters fire with a calculated burst, nudging the ribbon clear, avoiding any catastrophic encounter. Below, ground workers watch the crossing with bated breath, a collective sigh of relief as the danger passes. Then, they return to their stations, the rhythm of work resuming. On the ground, a contact trolley traverses the lower sections of the ribbon, a constant patrol. Every bond beneath the cloud line is scrutinized, especially after the fury of a storm. A lightning strike, a sudden violent discharge is anticipated. The ground strap, a sacrificial element, is immediately replaced. Workers keep spares ready, understanding this not as a disaster, but as a routine consumption, a planned resilience built into the very fabric of the system. Climber number 100 is loaded, its massive spool adding yet another layer. The ribbon at the tower guide now boasts twice its original diameter, a testament to years of continuous reinforcement. Damping masses, precisely calculated and clamped at strategic intervals, prevent destructive resonance, ensuring stability even when multiple climbers ascend simultaneously. By year 6, the factories retool, adapting their machinery for an even wider ribbon. The cable, now immensely strong, can bear the weight of heavier spools. 300 climbers have already made their journey, their cargo woven into the very fabric of this colossal structure. Guide rollers, once perfectly adequate, are replaced with wider bore versions. The cable has outgrown its own terminal, a living, growing entity reaching skyward. 14 years into this epic undertaking, the factories begin producing the final thickness of ribbon. The cable, nearing its ultimate completion, can now effortlessly accept a 100-ton load. In year 15, the moment arrives. The first true cargo ascends. Not mere reinforcement ribbon, but the vital components of the station itself. The cable, a monument to human ambition, proves its strength. A full load test confirms its capability. 100 tons suspended, a testament to engineering prowess. Terminal load cells register the design limits, confirming absolute integrity. Workers log the data, a quiet triumph, and clear the next climber for loading. The dream of reaching for the stars, once an impossible whisper, now has a tangible pathway, built layer by painstaking layer, rising with an unwavering resolve. From the scorched launch pads of Earth, a new genesis unfolds. While the colossal cable stretching into the heavens is meticulously reinforced by a dedicated cadre of climbers, a monumental structure begins to coalesce on the ground, the geostationary Earth orbit station. Piece by intricate piece, module by module, it takes shape under the relentless sun. Each completed section, a marvel of engineering, is then loaded onto the very rockets it is destined to transcend. The profound irony is not lost on anyone. The same fiery vessels that once defined humanity's reach for the stars are now constructing the edifice that will render them obsolete. This is the dawn of a new era, built on the shoulders of the old. High above, in the silent, unforgiving vacuum, the second module glides into position. A delicate ballet of precision and power. The latches engage with a soft, resonant thud that echoes only in the minds of those watching. Thousands of kilometers below, in the hushed port control room, workers confirm the lock. their faces illuminated by the glow of screens, each digit a testament to their unwavering vigilance. 26,000 kilometers up, a new world begins to form. On Earth, the gravity ring, an immense circular framework, is meticulously assembled in segments. This colossal structure, designed to rotate in orbit, will generate a simulated Martian gravity for the station's inhabitants, a vital safeguard against the ravages of prolonged microgravity. Simultaneously, the vast solar array trusses are painstakingly pieced together on the ground, their intricate hinges fitted with surgical precision. In the void above, these arrays will unfurl automa. At the geostationary Earth orbit, where the cable anchors itself to this nascent city in the sky, construction climbers cling to the ribbon of ultra-strong material. Robotic arms, extensions of human will, reach out with silent purpose, bolting the massive frame sections together with an almost organic grace. Yet the most critical work remains for human hands. Workers ascend the cable, a journey of 8 days, to reach this celestial construction site. There, in the disorienting dance of microgravity, they manually install the intricate internal life support systems, their shifts stretching across the silent expanse of space. Through every level of the station, cable guide bearings are precisely fitted. These critical components ensure the mighty ribbon of the space elevator can pass through the structure without ever making contact, a testament to the unforgiving tolerances of orbital mechanics. Finally, the solar arrays deploy, panel by gleaming panel, their hinges releasing and locking with a symphony of clicks, transforming the station into a radiant, power-generating beacon. The station at geostationary Earth orbit is complete. Humanity has built a city, not on a continent, but at an astonishing 36,000 kilometers above the Earth. The first crew, having completed their momentous work, descends from GEO by cable. They step off the dock, gravity a welcome embrace after 8 days of weightlessness. Their journey, 8 days up and 8 days down, marks not just a personal achievement, but the genesis of thousands more journeys to come. Back on Earth, another colossal endeavor unfolds, the construction of the counterweight. Block by massive block it grows, a staggering 12,500 tons of engineered mass. Assembled in its entirety before its ascent, this Leviathan will serve as the anchor point for the entire space elevator system, extending the cable's reach far beyond GEO. One by one, the counterweight modules are loaded onto specialized cargo climbers. At the dock, every kilogram is meticulously checked, every single unit logged. There is no room for error, no tolerance for oversight. Each module is then attached above geostationary Earth orbit, extending the cable ever further into the void. The counterweight swells, its mass accumulating at a breathtaking 96,000 kilometers, a silent, growing behemoth. As the counterweight's mass increases above, the tension on the cable at the terminal station below rises, a palpable force managed by unseen algorithms and human expertise. Workers monitor every kilo per scale, a constant vigil against the immense forces at play. Finally, the first passenger climber is fitted out. Seats, designed for comfort during the multi-day ascent, are installed. Life support systems, redundant and robust, are integrated. Viewports, offering an unparalleled vista of Earth and stars, are meticulously sealed. Workers fit every panel, every component, with an almost reverent cap. A full passenger loading rehearsal is conducted at the port dock. Every step of the boarding process is practiced, refined, and perfected until it is as swift and secure as boarding an ocean liner. Life support consumables, enough for the 8-day climb, are loaded. Workers inventory every single item, a final, exhaustive check before the hatch seals. The final checks begin: gripper alignment, power systems, communications. Workers run through the comprehensive list line by line, their voices calm, professional. Nothing is left to chance. Day 1. The climber begins its ascent, piercing the atmosphere, a silver needle against the blue. Day 3. It traverses the silent, dangerous expanse of the Van Allen belts, shielded by its robust hull. Day 8. Geostationary Earth orbit. Thousands of kilometers below, workers track every meter of its journey. In the port control room, every reading is logged. Altitude climbing, power beam holding steady, cabin pressure unwavering, all systems nominal. At the geostation, the waiting crew stands ready at the docking hatch, their faces alight with anticipation. After 8 days of relentless ascent, the climber appears below the station, a distant speck growing steadily larger. The docking arm, a graceful extension of the station itself, reaches out, ready to embrace its precious cargo. The future arrives. With a deep, resonant thud, the primary latches engage. A low hydraulic hiss confirms the integrity of the hatch seal. Then, with an almost imperceptible tremor, the massive portal slides open. For the very first time, a human passenger steps from the terrestrial cable into the vast, silent embrace of the orbital station. The second climber loads, a precise ballet of engineering. The same meticulous checklist, the identical sequence of operations. What was once a sprawling, hazardous construction site, the Earthport in the Pacific, now stands as a fully realized terminal, a gateway to the cosmos. The station, anchored at geostationary orbit, a silent sentinel. The counterweight, a distant Slive. A satellite embarks on its journey to orbit, not with the deafening roar of a rocket, not with a pillar of fire, but in absolute, profound silence. Workers, their faces etched with quiet pride, secure the hatch. The payload begins its deliberate, powerful ascent along the cable. The cost? A staggering $10 per kilogram to orbit. An impossible dream, pitted against the old paradigm of $2,720. That single stark number shattered every preconceived notion, redrawing the maps of commerce and exploration. One ribbon, it quickly became clear, would never be enough. A second port already takes shape, a testament to unprecedented demand. Another cable, meticulously planned, will soon join its twin. This audacious bridge, stretching from ocean depths to the vacuum of space, was not conjured by algorithms. It was forged by the unwavering hands of welders, the precise adjustments of climber mechanics, the tireless dedication of ribbon workers, and the vigilant eyes of control room crews. Every single bolt, along 96,000 kilometers of ascent, tightened by a human touch. The same specialized tools, wielded by the same skilled hands, on the ground and in the void. Now, 5 climbers glide simultaneously on the ribbon, 5 distinct payloads steadily moving towards their destiny. The system performs, not just as imagined, but as designed, a symphony of precision. At the port dock, a Mars crew boards, their faces alight with anticipation. They will ascend to geostationary orbit, transfer to their interplanetary vessel, and embark on a journey once confined to the realm of science fiction. Japan once dared to imagine this only on paper, in the quiet halls of theoretical possibility. Now, with every latch engaged, every seal confirmed, every climber ascending, that vision is not merely alive, it is the very pulse of humanity's future among the stars.